Okay, for this lesson, we're going to be learning how to use synthetic division to divide two different polynomials. The first example I'm going to give you is a very quick, shorter example just to show you how it works, and you'll be doing harder ones within your Delta Math lesson. So earlier in the year, when we were simplifying rational expressions, we knew that we were going to factor the quadratic on top. So if I wanted to factor this, what multiplies to 3 and adds to 4, that's the two factors, 3 and 1, so I could factor it as x plus 3, x plus 1, and I brought down my denominator of x plus 1 over. If something was in the top and bottom of my fraction, we knew that they canceled out, so I was left with my answer of x plus 3. There's a different method that you can do this called synthetic division. How you do synthetic division is you take the coefficients of your numerator. So if I have x squared, that coefficient is really an imaginary 1. And then I have my coefficient 4 and 3. I'm going to write those down here. You're going to take whatever you're dividing by and set it equal to 0. So I'm going to take the x plus 1, set it equal to 0. You could do this quick in your head, but by just subtracting 1 from both sides, you get that x is equal to -1. So we're going to place -1 on the left. And here's the trick for synthetic division. This first number in blue, I'm going to bring it down. So I have a 1 right there. Whatever is in this bottom row gets multiplied by this number out on the left. So I'm doing -1 times 1, and that gives me -1. And these two numbers that are on top of each other, I add. So 4 plus -1, 4 minus 1 gives me 3. And remember, this bottom row gets multiplied by this number out on the left. So -1 times 3 gives me -3. And adding up and down, 3 plus -3 gives me 0. And this last number right here is our remainder. Sometimes when you were dividing just by long division in like 3rd grade math, you ended up with remainders. Sometimes you didn't. Whenever it's 0, you don't have a remainder. So these numbers right here are the coefficients for my answer. And since we were taking a quadratic and dividing it just by a single x, we're going to decrease the degree of the quadratic by 1. So x squared just becomes x to the first, or just x. So I now have 1x. And then what comes after x, I'm going to decrease the coefficient. I'm going to decrease the degree again. X just becomes x to the 0, so nothing. And this 3 is just a constant. And you can see that 1x, which is the same thing as x plus 3, x plus 3 are two answers. I think usually when the examples are this simple with a quadratic in the numerator, I think the quicker way is to solve by factoring and canceling out. But it's not going to be so easy in the Delta Math. That's why we're using synthetic division, because we don't know how to factor something that has a degree of 3. So let's do this first example from Delta Math. I was given 2x to the 3rd minus 5x squared minus x plus 6. And I need to divide that by x plus 1. So I'm going to draw my little synthetic division table with coefficients. My numerator coefficients are 2, -5. This negative x is really like a -1, and positive 6. So 2, -5, -1, positive 6. And then we need to find out what goes on the left of it. Remember, that was just taking the denominator, x plus 1, and solving for x. So subtract 1 from both sides. We get x equals -1. Now we're going to go through. I need to start by bringing down my 2. whatever's in the bottom row gets multiplied by this number to the left. So 2 times -1 gives me -2. Add up and down, -5 minus 2 gives me -7. It's in the bottom row, so I need to multiply it by -1. -1 times -7 gives me +7. Add up and down, -1 plus 7 gives me 6. It's in the bottom row, so I have to multiply out by this -1. -1 times 6 gives me -6. 6 plus a -6 gives me 0. So we have a remainder of 0 again. And that's how all of these level 1 examples are going to be. You're always going to have a remainder of 0. So if you ever come up with an answer that's not remainder of 0, you know that you made an error somewhere and you need to fix it. So now I have my coefficients for my final answer. I started out with having a cubed, and I decreased it by just an x. So I'm going to decrease this degree by 1. So instead of it being x to the third, it'll be x squared. So it'll be starting with the 2 as the coefficient, 2x squared, and then -7, and I'm going to decrease by 1 degree. X squared just becomes x, or x to the first. And then I'm going to decrease by another degree. Taking away x to the first just becomes x to the 0, so nothing. It's a constant term, +6. So I can go ahead and type that in. 2x squared minus 7x plus 6. And we can do another example. Up. So for this example, we are starting out with x to the fourth plus 8x to the third minus 19x squared plus 19x minus 9. And we're dividing it by x minus 1. So I'm going to take all my coefficients from the numerator. This x to the fourth has the coefficient of 1. And then 8, -19, 19, -9. 1, 8, -19, 19, -9. We have to figure out what goes on the left over here. So we're taking x minus 1 and setting it equal to 0, whatever the denominator is. If I add 1 to both sides, I end up getting x equals +1. So 1 goes to the right, to the left. I need to bring this first number down. So I just bring down a 1. Now I'm multiplying everything in the bottom row by 1. So 1 times 1 leaves me with 1. Adding up and down, 8 plus 1 leaves me with 9. 1 times 9 gives me 9. -19 plus 9 gives me -10. 1 times -10 gives me -10. +19 plus -10 gives me +9. 1 times 9 gives me 9. -9 plus 9 gives me 0. So my remainder is nothing. And then we're looking at the degrees that we're going to start with for my coefficients of my answer. And we know that we started with x to the fourth, and we were dividing it just by an x. So I need to decrease the degree by 1. So x to the fourth is now going to be x to the third. So I have a coefficient of 1, 1x to the third. And then I decrease it by 1 degree, so 9x squared. Decrease it by another degree, -10x. Decrease it by another degree, +9 without an x. And we can always leave coefficients of 1 off of our terms. X to the third plus 9x squared, and it's 10x plus 9. And we can do another example. For this one, I'm starting out with 4x to the fourth minus 13x to the third minus 8x squared minus 21x plus 20 And I'm dividing that entire thing, that huge polynomial, by x minus 4. So I'm going to start out with my coefficients for negative 13, negative 8, negative 21, and positive 20. 4, negative 13, negative 8, negative 21, positive 20. I need to figure out what goes on the left, so I take my denominator and set it equal to 0. X minus 4 equals 0 if I were to add 4 to both sides. X equals 4. So I'm going to start this out by taking this first green 4 and bringing it down, which is just 4. Whatever turns into this bottom row, I need to multiply it by this left number 4. So 4 times 4 gives me 16. Negative 13 plus 16 gives me positive 3. That's in the bottom row, so 4 times 3 gives me 12. Negative 8 plus 12 gives me 4. 4 times 4 gives me 16. Negative 21 plus 16 gives me 5. Negative 5, sorry, because the negative 21 is bigger than 16. And then 4 times negative 5 gives me negative 20 for my remainder of 0. I know that I started out with x to the 4th, and I divided it by an x, so now my answer is going to have to start with x to the 3rd. So 4x to the 3rd, positive 3x squared, positive 4x minus 5. Let's do one more example. So I was given 3x to the 3rd minus 17x squared plus 12x minus 10. Now I'm dividing it by x minus 5. Take my coefficients, 3, negative 17, 12, negative 10. I know if in the denominator is x minus 5, I'm going to be dividing by the opposite, positive 5. Bring that first number 3 down to start. Multiply everything in the bottom row by 5. So 5 times 3 gives me 15. Negative 17 plus 15 gives me negative 2. 5 times negative 2 gives me negative 10. 12 plus negative 10 gives me 2. 5 times 2 gives me 10. And I have my remainder of 0. So our answer started out, our synthetic division problem started out with x to the 3rd, and I decreased it. I divided it just by an x. So my answer is going to decrease and be x squared. 3x squared minus 2x plus 2.